projects. In this video, we are going to explain about a project titled Credit Card Fraud Detection Using Machine Learning. In today's digitally driven world, credit card fraud poses a significant threat affecting the millions of users and the financial institutions globally. Our mission is to revolutionize the security measures by employing the advanced machine learning algorithms to detect and prevent the fraudulent transactions effectively. Throughout this project, we will leverage a powerful ensemble of classifiers within it. By meticulously analyzing the historical transactional data, we aim to develop an intelligent system that learns intricate fraud patterns and accurately distinguishes between the genuine and the fraudulent activities. The objective of this project is to develop an accurate and efficient credit card fraud detection system using the machine learning algorithms. By leveraging a comprehensive credit card transaction data set, we will process the data to handle the missing value and the outliers, ensuring it is ready for the model training through exploratory data analysis. We will gain the valuable insights into the data distribution and the correlations, addressing the any class imbalance with the smoothie technique. Implementing the diverse classifiers such as random forest, AdaBoost, SVM with linear and RPF kernels, KNN, decision tree, Gaussian naive-based logistic regression, and the light GBM. We will train these models to capture the intricate fraud patterns effectively. Evaluating each model performance using the key metrics and the fine-tuning hyperparameters will optimize their effectiveness. The final goal is to deploy the best performing model for the real-time fraud detection, ensuring continuous improvement through the regular updates and refinement to adopt the emerging fraud trends. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, importing the necessary Python libraries, Pandas, sklearn, matplotlib, and Smoothie. These libraries are crucial for data manipulation, visualization, model building, and handling the imbalanced data set. And the second one is importing the data set. Load the credit card transaction data set, which contain the liable instance of fraudulent and the not fraudulent transaction. Use the pandas to read the data set into the data frame. And the third one is data extraction. Explore the structure of the data set to understand its attribute, features, and the target variables. Check for any missing data or irrelevant columns that may impact the analysis. And the fourth step is data pre-processing. This step involves preparing the data for model training, handling the missing value by imputing or dropping them, remove any redundant or irrelevant features, and perform the feature scaling normalization to bring all the features to a similar scale. Proper data pre-processing ensures that the model performs optimally and accurately. And the next step is data oversampling with Smoothie. Check if the dataset suffers from the class imbalance, where one class has significantly fewer instances than the other. If there is class imbalance, apply Smoothie to generate the synthetic sample of the minority class, making the dataset balanced and avoiding the bias towards the majority class. And the next step is data exploration. Perform exploratory data analysis to understand the distribution of features, correlations, and patterns in the data. Use the matplotlib to create the visualization that provides the insights into the data characteristics and the potential relationship between the variables. And the next step is building the model. The first one is of random forest. It is an ensemble learning method that is based on the decision tree. It trains the algorithm on the pre-processed data set and will execute it. And the next one is AdaBoost. AdaBoost is also an ensemble method that iteratively improves the weak learner's performance and will be used to perform with of 70% of training and 30% of the testing data. And third one is support vector mission. Support vector mission with linear kernel. Support vector mission is a powerful supervised machine learning algorithm. It is used for the binary classification task where in this project it is used to classify whether the transaction is a fraud or not. And in the same way, the next step is support vector mission with the RPF kernel. It is also an powerful classifier that is used for the binary classification task, but by using of RPF kernel. And the next one is KNN. KNN stands for K nearest neighbor. It is a non-parametric classification algorithm that classifies the instance based on their proximity to the other data points. And the next one is decision-tree classifier, a tree-based classifier that splits the data into the branches based on the feature values. And it is also one of the powerful supervised learning algorithm. And the next one is Gaussian naive Bayes. Gaussian naive Bayes is a probabilistic classifier and it is based on the Bayes theorem. Here, it applied on the Bayes theorem to navigate it on the Gaussian surface. And the next one is of logistic regression. Logistic regression is also a linear classifier where it will be used to do the binary classification task. And this project of the fraud detection, the binary classification is of whether the transaction is having the fraud or not. And the next one is Light GBM. Light GBM is an gradient boosting framework that will be offers of high efficiency and accuracy when compared to the of other algorithms. Here also it will be used for the binary classification task where it takes of having the fraud or not fraud in detecting the transaction. And the next one is training the model. In this step, the models are trained using the pre-processed data set. Each algorithm learns from the features and labels to establish the pattern and the relationship, which are used for predicting whether a given transaction is fraudulent or not. And the next step is user gives the input. In this step, the user provides the input data in the form of credit card transaction. The model will use this data for making the prediction. And the next step is the given input is pre-processed per prediction. The user provided input data need to undergo the same processing step as of the training data. This ensures that the input data is in appropriate format and the scale required by the model. And the next step is trained model is used for the prediction. Using the pre-processed input data, the trained model predicts whether each transaction is fraudulent or not. The model predictions are based on the patterns learned during the training. And the last one is final outcome is displayed. The predictions for each transaction are displayed to the user as the final outcome. The user will be able to see whether each transaction is classified as fraudulent or non-fraudulent, helping them to identify the potential fraudulent activities in the real time. By this step, the credit card fraud detection system is built and ready for the use. This continuous monitoring and updating of the model will help of maintaining its effectiveness and ensure its adapt to the new fraud patterns over the time to time. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The input folder containing of the data set that we used in this project, and the model folder containing of pickle files which contain the information of the algorithm, and it will be loaded into the project code during the runtime, such as making the prediction on the new data, performing the specific operation. And the static folder contains of the folders like of CSS, JavaScript, images, fonts within it. And the template folder containing of the HTML documents like of home, image, index, model, predict, sign in and sign up pages within it. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that will be rendered in the HTML template. And signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda form. Here we need to change the location of the disk by using the cd space and paste this code folder path. By this, it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command, that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues, and then click on the enter button. After this, the app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser of our choice. And I prefer to use Google Chrome. I'm pasting this link and click on the enter button. Here it will redirect it to this page containing of the title of the project and contains of the sign in and sign up buttons within it. We need to click on the sign up button. Here it will redirect it to this page containing of some necessary details that need to be filled in. But my account is already created, that's why I'm using the sign in button. It will redirect it to the signing page containing of username and password that need to be filled as of admin. And then click on sign in button. It will redirect it to this page where we need to enter some input details. I'm entering it as of time 22 and the V1 as of 2 and the V2 as of 2 and the V3 as of 2 and the V4 as of 2 and the V5 as of 2 and the V6 as of 2 and the V7 is of 1 and the V8 as of 1 and the V9 as of 1 and the V10 as of 1 and the V11 as of 1 and the V12 as of 1 and the V13 as of 1 and the V14 as of 1 and the V15 as of 1, V16 as of 1 and the V17 as of 1 and V18 as of 1, V19 as of 1, V20 as of 1, V21 as of 1, V22 as of 1 and V23 as of 1 and V24 1 and V25 1, V26 1 and V27 to 1, V28 1 and amount is of 1. And then click on the submit button. Here it redirected to the result page and giving the final outcome as of analysis as 0. Here 0 means not fraud, and in this way we can detect this fraud credit card fraud as of not as a fraud by using the machine learning and the Python. And this is the comparison graph where x-axis represents the score of the each accuracy of an algorithm and the y-axis represents the algorithms we used in this project. And in conclusion, our comprehensive analysis of various machine learning algorithms for credit card fraud detection has yielded the valuable insights. Among the models tested, random forest classifier Light GPM demonstrated the high accuracy and robustness, while AdaBoost and SPM with the RBF kernel showed the promising results. KNN decision-tree, Gaussian airways, and logistic regression exhibited the moderate performance. The successful implementation of their stability for real-world applications, providing the enhanced security and trust in the financial transactions. Going forward, we recommend the further research to explore the ensemble methods and the data pre-processing technique for even more effective fraud detection system.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.